Good evening. I'm Eleanor Barker, the Executive Director at the American Computer and Robotics Museum here in Bozeman, Montana, and I'm thrilled to welcome you all to tonight's Source Code Lecture. Our topic, Artificial Intelligence on Your Terms, presented by Felicia Tan, who is joining us from the future. She's halfway around the world where it is already Wednesday, so that's exciting. Felicia researches human AI interaction and is pursuing her PhD at New York University's Tandon School of Engineering. Her work focuses on how AI systems are built, but also on how they shape the way people think, learn, and make decisions. Felicia has worked in venture capital and in an early stage AI startup, and she has seen firsthand how enthusiasm for emerging technology can outpace public understanding. Felicia is here tonight to help us navigate the maze that is AI, and she'll leave us with some thoughtful actions that we can take to maintain control when using this complex tool. Before we get started, two quick pieces of housekeeping. For those of you who need captions, and I count myself among you, you can turn them on by clicking the CC icon, the closed caption icon at the bottom of your Zoom screen. Or depending on the size of your screen, you can click the three dots labeled More and toggle the captions on from that menu. Also, we will reserve some time after the presentation for a short Q&A. So if there are any questions you'd like to ask, type them in the chat as we go, and we'll select a few to discuss. Now, please help me welcome Felicia Tan.
Hi, everyone. Thank you so much, Eleanor, for the generous introduction. I'm really grateful to share this next hour with all of you. I want to start by sharing a little bit about why I named this talk AI on Your Terms. I think at the core of our fascination and anxieties around AI, it's a really fundamental question of what does it mean to be human? What does it mean to be human now that machines can seemingly do many human things at a greater scale, perhaps, and perhaps even better than humans can? What are our values as people? What are we trying to protect? And how do we envision a good life for ourselves and for the future generations? If you had any of these questions on screen, you are not alone. I actually still have a lot of these questions, even though I spend a lot of time doing research on AI. It's hard to feel empowered by a technology that is so highly technical, and where the pace of change is so rapid that really, I think every other week or every other month, there's like big splashes of news on a topic, and really humanity is still trying to scramble to arrange itself around it. Our social systems, our laws, our schools, and our very sense of self, I really see that all of it is still catching up. And many of you know this, I'm sure. Charlie Chaplin in The Great Dictator, his famous closing speech where he breaks character to address the world directly. And this was 1940. So it was, of course, about fascism. But he also argued against dehumanization, mechanized dehumanization, and the idea of unchecked technological advancement. And really, a lot of these themes, I think, are timeless. The full line in this speech is about how machines have given us abundance, but not humanity. And they make us clever, but not necessarily kinder. So to me, at least, very relevant today in the context of AI advancements, and really a big part of what drew me to this field, why I have chosen to be a researcher in the field of human AI interaction. So what is human AI interaction? It's, researchers are still trying to come to a common definition of this subfield. But really, it's very interdisciplinary, and it sits at the intersection of computer science, design, and the social sciences. We're not the engineers directly building the AI technology or AI models, though we like to think that we influence those decisions. And we're the people asking what happens when those AI systems meet real human beings. So we ask questions like, how do we make AI that actually works for people? And how do people and AI systems affect each other? I'll share more about my research along the way, but we'll start by looking briefly under the hood at how AI works. We'll also think through some of the social and economic implications as we talk about risks. And I'll end by focusing on what we can control in terms of our interactions with everyday AI tools. Regrettably, I only have time to skim the surface on these topics, but my hope is to leave you feeling a little bit more curious, more equipped, and maybe a little more excited to keep the conversation going. Okay, this is Jensen Huang, the famous CEO of NVIDIA. AI isn't quite invisible software. It actually has physical manifestations in the form of high-performance chips, like the one that he's holding in that photo. I brought him up because he introduced the idea of the AI cake. He argues that AI is not a single technology, but a 5-layer industrial stack involving energy, power, land, hardware and chips, and connectivity through high-speed networks, and not to mention human capital, skilled labor, financing, etc. Some experts are calling this the largest infrastructural build-up in human history. We are literally rewiring the world to support this technology. I want to break down these layers a little today so you can understand how AI works. The term artificial intelligence has been around. The field started in the 50s, actually. But today, I'm specifically talking about generative AI. This is the type of AI that is behind applications like ChatGPT and Google Gemini. It runs in a slightly different engine, what we call large language models. That is an incredibly sophisticated and powerful model. We'll touch on that in a bit. For now, let's go back to the first layer of the cake. Energy. So every time we ask ChatGPT for something, we activate a massive surge of mathematical calculations across thousands of chips, all of which require high density, constant power. And while standard computers use general purpose processors, modern AI requires specialized silicon chips. You might have heard of GPUs, TPUs, NPUs. These are all specialized chips designed to handle massive parallel calculations simultaneously. So this is the Blackwell AI chip. It has 208 billion transistors. Transistors act here like tiny switches that control how data moves around. Now, you couldn't just plug a Blackwell chip into your home office wall. It would probably melt your outlets. These chips are designed to be clustered together by the thousands, and they function as a single massive entity called the supercomputer. So infrastructure here refers to the data centers, and I'll show a photo later on, that house these supercomputers and the thousands of chips. It is the kind of digital nervous system, the high-speed networking that allows computers to communicate with each other. The collective brain comes with a massive environmental price tag. So to keep them from melting, these buildings require staggering amounts of electricity for power and water for cooling. So a few years ago, 2024, US data centers alone used 183 terawatt hours of electricity. That's roughly equivalent to powering Pakistan for a year. In a few years, that's projected to triple. And water. Researchers estimate that every 100-word prompt every time you type 100 words into ChatGPT, we use roughly 500 milliliters, that's one water bottle, just in cooling the servers processing your request. And as AI scales, energy becomes as much of a societal bottleneck as it is a technical one. Questions like where do we build these facilities, which communities will share their water tables for cooling, who will pay for upgrades to our electrical grids. These are massive policies to be made, choices to be made, as you can imagine. And right now, these choices are primarily shaped by public and private partnerships, as well as industrial zoning laws, though they are definitely increasingly subject to local community, local environmental regulatory scrutiny. Now, the layers of models and applications are where the physical infrastructure that we've looked at so far finally turns into intelligence. You can think of AI models as engines of a car and applications as the car that uses that engine. The model is the core intelligence. And we'll talk about how that works later on, but it's essentially a massive bundle of mathematics and patterns trained on data. And the application is the outer shell, the website, the app, the interface that you interact with directly. And it turns this intelligence into a tool that you can actually use. So let's look at this one tool that many of us have interacted with, ChatGPT. This is an application that was built on top of a large language model, the engine. And while we interact with this application, and here it comes in the form of a chat and buttons with different features, the underlying model is doing the computational work in the background and generating what you see. So here I've asked it, I think it was, give me a recipe for vegetarian pasta. At their core, models are complex mathematical operations, and they are designed to calculate the next likely word based on the patterns that they've seen during training. It's actually not quite a word that they're predicting, but a chunk of word. But we'll just assume that it's a word for now. In the case of ChatGPT, when you type in your message or prompt, the underlying model predicts statistically what word is most likely to come next. Then it predicts the next word, then the next one, and the next one. So let's look at this video. Hopefully it'll make it a bit clearer.
Ever wondered how AI models like ChatGPT actually respond to your questions? When you ask a question, these AI models don't actually think like a human. Instead, it just predicts the most likely next set of words based on the data that it was trained on. But how does it work technically? Under the hood, they use something called a transformer, which is used to scan the text, find the context, and then predict a response word by word in real time. So when you ask a question like, why is the sky blue? It doesn't actually know what the answer is like a human. So no, it's not magic, just maths and probability. Still pretty cool though, right?
Very fascinating technical capability. It starts first with what you type, so your input into the prompt. I asked just now for pasta recipe. And the model, which has been trained before on a lot of human data, then scans its memory to find patterns. And it is essentially calculating the mathematical probability of which words should follow yours. And finally, it generates the result. That's what you see. So it isn't quite retrieving it from a database, unlike Google search in the past. It is a brand new string of words that's constructed one prediction at a time. An AI tool might appear to think or know or understand or even feel, but the underlying mechanism is statistical pattern matching. It does this so brilliantly that that its outputs essentially look human-like. To create a predictive model like that, engineers need to first train the model. So part of what makes AI models so powerful is that it learns from a staggering amount of content. This content includes the public internet, billions of books and articles, code repositories, forums, and images, and a process where people rated which responses sounded better, human feedback. There's an implication here worth pausing on. The models have absorbed not just human knowledge, it has also absorbed human junk, human bias. Every stereotype, every historical mistake or inequality, all of that is encoded in our writing. So it has learned from all of that too, because it's in the training data. And we'll talk a little bit more about the idea of bias in models at a later section. We call these large language models because they require a large amount of data, resources, and talent to build. To give you a sense of the scale we're talking about, this infographic shows the price of admission. So the cost of training a single model has rocketed from millions to hundreds of millions of dollars in just 2 years. Because building these models are so expensive, a new business model has emerged. It's called model as a service. And one more distinction. ChatGPT is a kind of general purpose AI. You can think of it as a jack of all trades, and it tries to do everything. You can ask it to write poetry, debug code, plan a travel itinerary, a recipe. It is very versatile, but it's also a generalist, and it's best used for tasks where accuracy isn't the goal. Specialized AI, on the other hand, on the right, that usually does one thing and it does it with greater precision. So some of you might know the Merlin Bird ID app that was built for the purpose of helping people identify birds. AlphaFold is another very popular application, a specialized application used to predict the shape of protein to cure diseases. And radiology AI is trained to find anomalies in X-rays, anomalies that the human eye might miss. When someone says AI diagnosed this, AI wrote that, it's better to ask which kind. You might want to ask how it was trained. And my opinion is that a domain specialist and a general chatbot warrant very different levels of trust. So let's dive into the impact of using AI as a tool in daily life. Where exactly does it excel, and where do humans remain irreplaceable? Speed is a genuinely impressive thing about AI. It processes at a skill that no human can match. So think of dropping 20 thick novels into your ChatGPT prompt. It's able to read and establish connections between them in seconds. AI is great at pattern recognition and synthesis. It's currently rapidly being adopted in the medical field for this very reason. It can find a scan and scan thousands of medical images in seconds to flag anomalies like a stroke or a tumor. And in finance, it can analyze spending patterns, then spot a fraudulent transaction in milliseconds. And while humans think linearly, one at a time, AI chips like the ones that I showed just now can look at millions of data points simultaneously. And repetition, AI can do the same task consistently with the same level of precision without fatigue, boredom, or variability. We humans are brilliant, but we are biologically wired to get bored at some point. One of the things that AI has changed is who gets access to information and how. It is powering real-time captioning, like the one that we're using right here on Zoom, that's powered by AI. Real-time captioning is a kind of assistive technology that was originally designed for the deaf and hard of hearing. AI is also currently powering communication aids for people with speech disabilities, tools that can predict, generate, and speak on users' behalf in real time. A research lab that I was a part of at the National University of Singapore worked a lot on technology for people with visual impairments. This one tool here is called IC. It is a wearable headset with a built-in camera and audio. Most assistive tools stop at being functional, so they help you identify the object that you're holding. IC goes a little bit further because it's powered by AI. It lets you have a back and forth conversation about what you see. You might ask something about the context of what you're seeing, for instance, and it's able to answer in real time. And it also works as a standalone device, so no phone needed. And it uses a bone conduction design for audio, which means that sound is transmitted through the bone. And so you don't have to cover your ears like the earphone that I'm using right now. You can stay aware of your surroundings essentially when you use it. The overall goal of most assistive technologies is to enable independence. But I think what was interesting about observing the process, the development process of IC, was that the team actually spent years working directly with visually impaired users, both before and throughout the building process. And unfortunately, that's rarer than it should be. In this field, we see a pattern where sophisticated tools are built, but users don't actually want them, or maybe they can't afford them, or they won't use it in public because it draws too much attention, for instance. So users are brought in late, usually for validation rather than genuine co-design. And by the time someone with a visual impairment sits down to test the device, the fundamental design decisions have been made. And their feedback really is just to adjust the surface, but not the structure. So the irony here is that the people with the most to gain from good design often have the least influence over it. And we call this participatory gap, an issue that more and more researchers are becoming aware of. There's also a broader problem where AI is being added to products not because it solves real problems, but because it signals a kind of technological sophistication to funders, perhaps, to the press or to the market. And we call this technology push, where capability is driving design rather than need. The uncomfortable part is that these tools still get published and celebrated because the metrics that we use to evaluate them rarely include whether a real person in a real situation actually wants to use them. So let's hold that question. I want to turn our attention to another case study where the builders and the users were largely the same people. So the Bird app that came out of Cornell's lab, it's built for birders, by birders. The use case here was clear from the start. Help people answer the question, what's that bird? And what makes it interesting is where the data comes from. The data model is where birders around the world log their sightings on a public database called eBird. So things like location, species, date. And this database now holds hundreds of millions of observations, reviewed and annotated by expert birders and used to train Merlin's AI. The community collectively contributed to the dataset, and that dataset was used to build the AI model that powers this app. And now those who benefit from using this app can start logging their sightings too. So the community grows and the database grows and the model improves and it feeds itself.
This has been the most popular bird in New York for weeks.
Crowds are gathering behind me to catch a rare glimpse of the American woodcock here at Bryant Park in New York City. Take a look.
Any day now, it'll continue its migration north. The viral moment won't last, but birdwatching in the US is having a moment, powered by tech, AI, and social media. Apps like Merlin Bird ID and BirdNet use machine learning to identify thousands of bird species in real time
Using sound and images.
effectively turning smartphones into a Shazam for birds. 16 million people used Merlin in 2025 alone, a 50% jump over the year before. Tech like this is lowering barriers for beginners while also feeding real-time data into citizen science platforms like eBird. Birding is now one of America's fastest growing pastimes and a multi-billion-dollar business. The pandemic kicked off the boom and the hobby stuck.
Call ourselves pandemic birders, but it gave us, gave us something to do when the world shut down.
Cornell's Lab of Ornithology found 63% of Americans reported birdwatching more in 2020 than in years past, and bird feed and backyard feeder sales jumped nearly 50%. Today, nearly 96 million Americans, more than 1 in 3 adults, are birders.
It's interesting to look at this technology through two lenses. First, notice the positive cycle. how this technology is lowering barriers for beginners and turning a once niche hobby into a bigger movement. It's really a beautiful example of how humans and AI can change each other for the better. But I also want to challenge you to consider what happens when we stop relying on our own ears and eyes. So here's a quote from an article. My fear at first was I wouldn't actually learn because I'm outsourcing my understanding of birds to this app. There's no real substitute for a real person explaining to you how a bird song feels and encouraging someone to engage with it emotionally. When we outsource our curiosity, our knowledge, discernment, and when we remove the need for human-to-human connection to an app, there are really hidden costs. And this is a core concern driving my research at New York University, this idea of de-skilling. In the past, technology helped us outsource our muscles. Think of a washing machine or a car. But the AI tools today we've looked at, the Merlin app, ChatGPT, they allow us to outsource our thinking. Many of us use Google Maps or Waze or Apple Maps for navigation. These apps use AI predictive modeling to calculate traffic and routes, which really help us. But GPS technology as a whole has changed our abilities to recall landmarks and form mental maps, even of places that we visit regularly. And our ability to remember information and engage with our own writing and ideas has declined too. When we outsource a cognitive skill, we risk de-skilling our very ability to think, to reason, and perceive the world around us. In a similar vein, a study published last year surveyed over 600 people across different age groups and educational backgrounds. Frequent AI tool use was linked to lower critical thinking ability. And not so surprisingly, but very worryingly, the study found that younger participants showed higher AI dependency and lower critical thinking scores compared to older participants. That pattern, when extended across younger generations, especially today growing up with AI as a default tool, is what I think is concerning. And critical thinking is just one aspect of human cognition. We humans have a rich and full range, including creativity, learning, planning, collaborating, decision-making, etc. These are all muscles that allow us to navigate uncertainty in our lives and disagree productively and create things that matter, create things as a process of personal expression. I want to share an interesting finding from my recent research at NYU. It reveals a kind of glitch in our psychology. So we ran an experiment with 240 participants, and we asked them to do various online tasks like writing and brainstorming, evaluating text. They were asked to use GPT as an AI assistant. What users did not realize was that we varied the AI assistant's response time. Response time here refers to the pause before the AI answers. People rated the slower responses as more thoughtful and more useful, despite the fact that the underlying AI model was identical, meaning that the quality of advice didn't change, only the response time did. The AI basically seemed more credible when we slowed down its responses. And why is an interesting question here. We project human social norms onto the conversational AI system. In human conversations, pauses in the right places can signal careful thought. So if someone took more time to respond to your question, you might think, hey, they really care or they're deliberating deeply. So we can't help but read the same cue in AI, even though AI is just a machine. The question of what remains distinctly human. Things like judgment, perhaps, where you have to weigh complex trade-offs, when you know when the rules apply or do not apply. Ethical reasoning, knowing that a technically correct answer might still cause harm. Context awareness. For instance, a human is able to understand when a sentence changes meaning, depending on who said it or how they said it. And intuition. the ability to sense things that are not immediately observable. These are uniquely human skills that emerge from lived experience, and these are qualities that an AI can statistically simulate, but never authentically possess. Okay, so I want to shift gears and talk about the risks of AI in greater depth. I think at the core of this is an acceptance that AI is not always correct or accurate. Here we have a kind of popular internet meme. It's a visual parody. At the top, it reflects our big cinematic cultural fear. AI will take over the world. Machines are going to take over the world. But on the bottom, we see that the AI detection is not getting it quite right. That's a technical term for when AI generates false information with total confidence, and it's called hallucination. There was, in fact, a landmark case a couple of years back where two experienced New York lawyers used ChatGPT to research case law. And their brief cited multiple cases with names and numbers and judges. The problem was that none of them existed. The AI had fabricated them from scratch. When the lawyers asked the AI to verify, it actually doubled down, insisting that the cases were real and could be found in any library. The judge called the final result legal gibberish and fined the lawyers $5,000. One of them later said that he thought that the AI tool was a super search engine. And in this news article here, you see that he said he was unaware that an AI program could produce fake citations. AI is a predictive engine, not a truth engine. So the lesson here is really to always verify an AI output against a trusted source, because most of these tools are designed to prioritize sounding convincing over being correct. Hallucinations come in a couple of forms, and a common one is factual error. So here it says that the Eiffel Tower was built in 1901, but really it was before that. A really dangerous one that we heard about just now is fabrication, making up something that has never existed. There's also prompt contradiction. So you ask for one thing, the response is not quite giving you what you asked for. In this case, the AI model has lost track of what you wanted. And occasionally something even more frustrating. I actually encountered this a couple of days ago. Completely random output with no connection to what I asked. It can happen when a long conversation starts to blur the model's sense of what you're actually asking. So context, which is your history of chat, it starts to build up, and somewhere in that tangle, it loses that thread. Why does this happen? So the internet has limited or incorrect information sometimes, and the model learns from that. So we're talking here about data quality. If you ask also about something obscure or recent, it might not have been trained on relevant data. So it's forced to generalize beyond its training data. It has no clean pattern to follow, so it just produces something that kind of fits the shape of the correct answer. You'll see the nouns and the sentence structure and plausible dates and credible sounding citations, but all made up. Independent of the data, the AI model, this is more of a technical topic, but the AI model can itself introduce errors. Things like novelty bias, where the model is rewarded for interesting outputs at the cost of accuracy. That's one example. The third cause of vague and contradictory prompts is really where we have some control, and I'll talk about that in a bit. Like a human listening, it's not going to understand you very well if you don't provide clear instructions or sufficient context. So if you say something like, is Mars nice? You might want to specify that you meant Mars bars instead of the planet Mars. We cannot eliminate hallucinations technically, but we can significantly reduce our exposure to them. And the single biggest lever is your prompt. The more you narrow the task, the less room the model has to fill gaps with invented content. So be specific and give it context. You can also tell the AI, say, I don't know if you're unsure. It's been trained to answer you, so sometimes you need to give it permission not to. You can ask the model to cite sources and then check if those sources exist. And for anything time sensitive, you can actually ask the model what its knowledge cutoff is. Here is literally what I did. And the AI assistant said that the cutoff is August 2025. So I know that I shouldn't be asking about the Iran war timeline, for instance, as it genuinely can't know. One more thing you should do is to start a fresh conversation and ask the model to critique its previous answer. It often catches what you missed because the errors become visible in a new context. Now, bias, huge problem. The phrase garbage in and garbage out really explains why AI tools are not neutral. Because it's trained on historical records and it inherits the biases of human beings, our past. For instance, if it's trained on 50 years of mortgage approval data from a time when, say, certain neighborhoods were excluded from getting loans, then it learns that pattern. We'll look at some documented examples, but it's really important to realize that bias is not always visible or intentional, but it's definitely something to be wary of when we use AI tools for high-stakes decision-making. So Compass is an AI-driven tool used in US courts to predict whether a defendant will reoffend. A famous 2016 investigation found that the math was heavily tilted. Black defendants were twice as likely to incorrectly be flagged as a high risk compared to white defendants. And an MIT researcher tested facial recognition systems and found that error rates for light-skinned men was less than 1%, but for dark-skinned women, it jumped to nearly 35%. These exact systems were being used by law enforcement to identify suspects. Even the world's tech giants are not immune to this. So Amazon spent years building an AI recruiter to find the perfect job candidate. But they had to scrap the entire project a few years ago after discovering that the system was systematically downgrading resumes that contained the word woman. Once again, AI models learn from historical data that it's fed. And if that data contains centuries of human bias and uneven policing, then the AI doesn't correct that bias, it automates it. This next topic is one I feel very passionate about because I myself and people around me have been victim or almost victim to AI-enabled scams. So let's take a look.
Now, a case of doggy blackmail. A family gets a call that their dog was hit by a car. They say they were even sent this photo of their dog being treated at the vet, but it was all fake. The photo, AI. Les Trent tells us what's really going on.
It's a blackmail caper stranger than fiction. This couple says they returned home to find their beloved dog missing from their backyard.
We were so scared. We didn't know what had happened to him.
Then came a phone call. Their 11-year-old beagle mix named Archer had been found. They say they were sent this photo showing the poor pooch with a terrible wound being prepped for surgery. Bill and Allison Cousins say the caller identified himself as a vet and said Archer had been run down by a car.
He was going to have surgery because he had a broken femur and a dislocated shoulder. And we were like, yes, whatever needs to be done.
Archer's panicked owners were told the surgery would cost $2,746. They were willing to pay up, but then they realized some things just didn't add up. First, they received this text instructing them to pay with Walmart or CVS gift cards. Then they were sent another photo of Archer post-surgery, this time with fancy bandages.
I'm like, this is exactly the same as the first picture, just the two doctors had moved.
And look at the date on the x-rays.
It says 12/21/2022.
Wow, almost 4 years ago.
Correct.
Turns out the photos were entirely AI generated. The AI scam failed, but the heartbroken owners were still missing their dog, Archer. Then, 4 days later, Archer suddenly showed up at their front door in Deltona, Florida. Here he is. Hey,
Here's
Archer.
our Archer.
Without being able to make a buck, the dog napper apparently decided to return Archer.
Archer,
Hey, buddy.
how do you try to take advantage of people when they're at their most vulnerable? Like, that's disgusting.
Archer's owners think he was confined because he's walking.
My perspective here is that the core issue with these scams isn't actually AI. It's a human issue, but it's about how some of us have chosen to use these tools maliciously. Some ways in which AI can be used to scam include voice cloning. From just a few seconds of real audio, you can clone a voice. You can use it in a call that sounds exactly like your child or your grandchild in distress asking for money. You can make a realistic video of someone saying something they never have. So these deep fake videos, they're called that, are used not just in fraud or manipulation, but in reputational attacks. AI-enhanced phishing is where you write personalized, convincing emails, for instance, impersonating employers or banks or loved ones. Overall, the situation has been getting out of hand. This chart here shows an increase in deepfake fraud cases around the world. And the US, on the top left, there was a 3,000% increase between 2022 to 23. So for every one scam reported in 2022, there were 30 in 2023. Talk about a booming industry. And as tempting as it is, I can't give you a list of every trick a scammer might have. All I can say is that they're trying and they're getting better and smarter. So I'd encourage you to look into this more. There are excellent resources online. I've included some here on the slide. And if you do nothing else, just Google the words AI scam or YouTube, search it. There are tons of engaging, entertaining material, but really it's important to start recognizing the patterns so that you stay ahead. And very quickly, I want to talk about the topic of AI-enabled surveillance. As you can see from the chart here, the surveillance market is set to explode to 20 billion in 2030. In some cities in China, if you jaywalk, your face is identified and displayed on a public billboard in real time. And scores affect when you can buy a train ticket, get a mortgage, or send your kids to certain schools. Not just China, but worldwide, we're grappling with the same questions of surveillance. How much of it and in what ways is this warranted? There are security risks that come with advancements in AI too. Just last month, news came out that a model called Mythos by Anthropic proved so powerful at finding software vulnerabilities that its creators refused to release it to the public. In just 7 weeks, this AI model uncovered thousands of security flaws, including a vulnerability in a software that banks and government agencies use to protect sensitive data. AI spotted that vulnerability within seconds, even though humans had been looking at it for many years without seeing the problem. A final risk I'll talk about relates to economic disruption. We have big tech companies that reduced new graduate hiring by 25% in 2024 compared to the year before. Entry-level white-collar work tends to be the first to go in the current disruption cycle. In the first half of 2025 alone, nearly 78,000 tech jobs were directly attributed to AI displacement. That's about 430 per day. The optimistic framing is that technology transitions will create new work. The World Economic Forum projects that many more roles will emerge than jobs are displaced. But transitions are not frictionless, of course, and they take time. And the people best positioned are those with AI literacy and access to reskilling. Okay, so I touched upon a couple of topics. I want to end on something a bit more practical. Many of the risks that I talked about, like surveillance and labor disruptions, these are societal questions requiring collective action. But there's a lot that you can actually do right now in terms of your daily use of tools like ChatGPT or Google Gemini to engage more safely and effectively. Starting always with how you talk to them. So the way you phrase a prompt directly shapes what the model generates. And this is what researchers call prompt engineering. And you don't need an engineering degree for that. You just need to know how to craft your prompts deliberately so as to get better outputs from a large language model. So you can try this phrase here on screen. If you don't know, don't make things up. I think I alluded to this just now. This works because you're explicitly adding behavioral constraint to the context. And this framing steers the model towards admitting uncertainty rather than making something up. You can say, think step by step. This is a very well-studied technique. It's called chain of thought prompting. And research shows that it improves performance on reasoning tasks. By asking the model to decompose a problem, you're forcing it to generate intermediate steps, which reduces the chance of leaping to a wrong conclusion. You can ask the tool to structure information for you in tables or to summarize information into bullet points. These tend to lower risk because you're not asking it to generate new facts. You're asking it to reorganize what's already there. Are you sure this appears wrong? So this triggers what's called self-consistency checking. The model reevaluates its previous output against your challenge. It doesn't always correct itself, but often it's enough to get it to check factual claims. And finally, you can have it adjust complexity to your needs. Something like, explain this like I'm not a specialist, or explain this like I'm 10 years old. This works because models are trained on text written at many different levels: academic papers, textbooks, Wikipedia, blog posts, etc. When you specify your level, you're narrowing which of the registers the model draws from. The broader principle here is the more specific and constrained and clear your prompt, the less room the model has to fill gaps with invented content. And a great rule of thumb here is to trust but verify, like so many things in life. You are still the gatekeeper of your own privacy. There are different opinions of this online, and it also highly depends on the model you're using and its safeguards. But as I personally never share personally identifiable information such as SSNs, medical records, passwords with an AI. Anything that you type can potentially be logged or stored. And we're talking about sometimes not about the safeguards in place, but malicious actors who try and break those guardrails. The second rule is to verify what comes out. To use AI as a starting point is usually helpful, but never as an ending point. If it gives you a citation, a legal citation, a medical claim, or a statistic, always verify it. And finally, be aware of the risk when AI is used against you, scams, for instance. So always stay updated by reading up about it. I'll end with a simple framework, 3 questions to take home, 3 questions you can invoke before you use an AI tool, new or familiar. So what am I giving up? Is it your data, privacy, or potentially effort that will help you build a new skill? It's not always a bad trade. AI is, after all, a tool of efficiency, but the trade-offs at any one moment are worth exploring. Another question is, who built this and why? Every AI tool was funded by someone, some organization, optimized for a purpose that may not align with yours. A free tool has a revenue model somewhere. So it's always interesting to dig deeper into who built what and why. Finally, Can I verify this output? Verify anything consequential using AI as a collaborator and a starting point, as mentioned, not as an authority that ends the conversation. I'll end with this lovely quote from the same movie, The Great Dictator. We just scratched the surface today, but my encouragement would be to keep learning, to read widely, to watch interviews, seek out voices that are close to the work. I personally subscribe to newsletters written by engineers and researchers and policy designers who are inside these decisions. And I feel that proximity really matters. And to engage in these conversations with your colleagues, your families, your communities,